All right, you know what? Let's get started. Welcome and thank you so much for joining us for another HRAI webinar. My name is Matthew Bradford, your HRAI host, and today I'm joined by Sam Molyneux, co-chief executive of Poppy. He's going to be taking us through achieving sustainability and healthy building goals with new methods from ASHRAE 241. Before I let him do his thing, I'm just going to do a couple of housekeeping items. And if you were here before, please bear with me because you probably heard this repeated, but this is being recorded. You'll be able to watch it on HRAI's YouTube page, share it with your people. And also, if you have questions, we are taking those at the end of the presentation. You can find at the bottom of your screen a Q&A box and a chat box. Pop them in either one of those. I will be looking at those, and we'll handle them at the end of the slides. And also, too, if you ever want to put on a webinar of your own, please reach out to HRAI's, get us through the website, and we can make that happen. But enough of me talking. I'm going to put it over to the expert who you can see on your screen right now. And take it away, Sam. Thank you so much for joining us.
Thanks so much. Thanks so much, Matt. And thanks everyone for joining us today. Hopefully you've got some lunch in front of you if you're on the East Coast, and if you're on the West Coast, just getting into the office, you've got some coffee. I'm going to give a talk today about 20 minutes, keep it short and sweet, but then happy to dive into everyone's questions about the standard, the new measurement method that we're going to talk about today, or your applications. Sorry, my slide is taking a moment to change. There we go. So a little bit about us very quickly and the company I work with. So as Matt mentioned, I'm Sam Molyneux, co-chief executive and co-founder at Poppy Health. We are a San Francisco and Toronto-based HVAC and indoor air technology company, and we've been helping clients create sustainable and healthy buildings since just before the pandemic. We work with some of the nation's leading scientists in fields like aerosol, environmental engineering, and infectious disease. And a lot of what I'm going to be talking about today is actually sort of based around those areas, and that's what our backgrounds are in. So the test that we're going to talk about today, too, the particle decay test of ASHRAE 241, is something that we have a tremendous amount of experience with, and happy to answer questions around based on this experience. So we've used it in nearly 1,000 locations across North America and Europe at this point, in a wide variety of space types. Part of what you're going to hear about today is the application of ASHRAE 241 to different space types that have different clean airflow requirements. And that's the kind of thing that we've been doing quite a lot of, everything from Class A offices to airports, factories, commercial spaces, and even marine applications. Okay, so to get into the talk, why airflow and ASHRAE Standard 241 matters. So we all lived through the pandemic, fortunately, and we're all very, very acutely aware now of the relevance of indoor air, clean air, and how it affects respiratory infections, specifically, typically viral infections. We're going through seasonal waves right now. Many of you are probably sick with something, or one of your family members is. You're getting through a cough or cold, and it is now understood that the vast majority of these infections are acquired indoors. It turns out that if you look at global disease burden, about 14.1 billion cases annually of disease are a respiratory infection. Many of these probably are transmitted via airborne routes, as is now sort of thought to be the case. And that comprises about just under half of everything anyone gets sick with every year, about 43%. So clearly this is a key problem. It's a key problem for your occupants and for people who use your facilities. And it's one that both we lived through the pandemic, but now there's also been a reaction to by ASHRAE, which is the organization that sets standards for indoor air. And that reaction is ASHRAE Standard 241, which is a standard that I had the honor of helping to contribute to through the first half of this year, and it was published in July. So the goal of this standard is to reduce the risk of long-range viral transmission indoors, and really the goal is actually to even out the risk as we walk through our various indoor spaces in society, even it out and reduce it to a low and controllable level. And if you imagine all the spaces that you walk through today, some of them are well ventilated, some of them have high levels of clean airflow, some of them have very low levels, and everyone has this intuitive sense that the places that we have lower airflow, those are the ones that there's higher risk. And so ASHRAE Standard 241, the core concept of the standard is actually targeting the rate of airflow so that we can have efficient viral transmission reduction in all of our spaces. But then that opens the question of what is the right amount, which is something that the standard tells us for a variety of space types, and then how to apply that to our buildings, depending on the activities that are being done in the space, the occupancy, and how to verify that we've got the right level of airflow, how to commission that, how to measure that. So when you open up the measurement question for buildings, that also gives us an opportunity to find spaces that may have more clean airflow than is needed to provide these target rates of viral transmission reduction. And so as part of ASHRAE 241, there is a new measurement method called the normative Appendix C method for particle decay. And that method tells us actually how to measure clean airflow rates in a more comprehensive way than before. And this allows us to actually apply this and find potentially overventilated spaces, opening up energy savings opportunities. And of course, those underventilated are under low airflow spaces that are probably the spaces that have most of the risk of viral transmission. So Standard 241 is, it's talked about as a once in a generation standard for raising the bar on indoor safety. It defines new requirements for all building types, both new and existing buildings. It prescribes minimum clean airflow requirements for the control of infectious aerosols. And it does this by defining the amount of clean airflow per person for 95% reduction in airborne transmission. It defines a new running mode for buildings, one called infection risk management mode, or IRMM, which you can think of as different from your normal mode. So if your normal mode is defined by ASHRAE 62.1 or 62.2, which tells you the minimum outdoor air ventilation per person for CO2 reduction and for removing body odor, ASHRAE 241 defines a higher rate of clean airflow that also takes into account other ways of providing clean airflow. So for example, filtration. And it defines this as a mode that can be activated and run during seasonal waves of infection. It could be called on by public health, or it could be activated just by building and facility managers, depending on what's happening in that geography, depending on how they use their building. So it does enable operators to choose the target occupancy level for the IRMM in each space. And this is a key variable that they have or lever for controlling the cost and amount of clean air that they wish to provide and can afford to provide for the space. So in part of what I just said there, I've defined a couple new things. So one is normal mode versus infection risk management mode, or the 241 mode, a mode that can be activated voluntarily or called on by public health. It also defines something called a building readiness plan. And this is a plan that documents how the infection risk management mode is actually achieved in the building when it is activated. So part of what 241 gives us is a roadmap or a set of targets to hit for clean airflow per person that depend on the space type. And we can't give you the numbers here. You'll have to download the standard for that. But you can see how the numbers vary depending on types of spaces. So lower numbers in, for example, industrial spaces, higher numbers in places like gyms, not surprisingly, or in waiting rooms in hospitals. And these numbers were defined by a infection risk modeling process that was used as part of the standard that looked at activity types, densities, and other risk variables for these space types. And by robustly modeling that using some of the best published science that was available at the time, we were provided with these targets, and they can then be used to measure spaces against and to run our HVAC and air cleaners against to provide clean airflow from a variety of alternative sources. So intrinsic in what we're saying here is that we have a set of targets, and if we're already above those targets for our spaces, we may be overventilating the space. Now that might not be a bad thing from a health perspective, and certainly, more air is probably better, or more clean airflow is probably better. But at the same time, there may be diminishing returns from an infection risk reduction perspective. And second, we do have to balance cost. And as we're going to talk about partially today, providing conditioned air to buildings is and remains the number one cost for from an operating perspective for any building. And so the new measurement method from 241, the particle decay method, enables us to measure where we're at today to determine our total clean airflow that we're providing zone by zone or space by space for our buildings, and determine if we're already above that. If we're below, we know that we may need to add additional clean air sources and measure again or calculate again the contribution of those clean air sources. And ultimately, where we want to be is knowing that we can achieve a target total clean airflow rate for each space, knowing how to activate that when we want to activate that during seasonal flu or in our IRMM mode, and how to go back to normal mode as well. And so 241 really provides us with a number of tools to achieve this that we didn't have before. So normative Appendix C in 241 outlines a new method for measuring comprehensively so, or nearly comprehensively so, the clean airflow rate that we're providing to a space. So the particle decay method is a method in which tracer particles, or simple salt particles as it's outlined in the standard, are added into the air from a diffuser device. This is a mist of salt water that's added. The salt water dries quickly into small inert salt particles that can be added into occupied spaces, and a test setup of particle counters that can measure the removal rate of those particles. The magic of this method is that by doing this, we are measuring the ventilation and the filtration at the same time in the room, in the breathing zone, where people are interacting in relevant test zones throughout an occupied space. And in doing this, this is the most accurate known way to measure the particle removal rate, or equivalently the clean airflow rate that's ever been devised. And this is a new method for the HVAC industry. A couple different features of it and its value. So one is it provides a nearly holistic view. So while it won't measure the inactivation rate that's added through UV, for example, or other air cleaning devices that don't use filtration, ventilation and filtration are the most common ways and often cost-effective ways to provide clean air to spaces. And this will measure those as a combined effect directly, along with particle settling and other passive particle removal methods that are actually active in a space and do affect how human breath that may contain pathogens is removed from a space. This new method is a pass or fail method for determining if you meet your target clean airflow rate depending on the occupancy and the space type. But it also tells you quantitatively where you are versus that, so that you know how much to add using additional devices or optimization of your HVAC system. And it's also worth noting that this is a more comprehensive method than a traditional tab airflow survey that uses vent face measurements to measure the CFM of air that's coming out of your HVAC system, because it doesn't require an assumption of rooms being well mixed. In fact, it measures directly the removal rate in the breathing zone, regardless of the mixing state of the room. And it's designed in a way that with new types of technology, which I'll talk a little bit about today, can be done very, very cost effectively and also scalably throughout large portfolios. So this is different than other air quality measures. It enables you to measure directly the equivalent clean air, or ECAI, for 241, the amount of clean air delivered per person. It lets you measure directly the total clean air per person, which is ECAI times the occupancy. And it also gives you another metric that's helpful called effective air changes per hour, which measures how often the air in a space is replaced for the particles that we're measuring directly using this test. So this is not the only way to meet 241. It's the only way to measure directly those variables, but you can add up all of the clean air sources in that you have for a space, all of those alternative sources. You have to then also go and verify system function and test those systems, and you do need to do a tab airflow survey every 3 years as an alternative. And so the attractiveness of the normative Appendix C test is that you can simply measure directly and avoid doing all of this other work, assuming that you are able to meet the clean airflow requirements. And if you don't, then you add your additional sources and measure again in an iterative cycle, which can be done quite easily. So this is something that at Poppy we have a lot of experience with. We've built this into an automated system now that enables you to set up sensors and nebulizer and quickly deliver this data on site so that buildings can be optimized in the moment when you have the contractors on site with you. We have been discovering that buildings in the Class A space are often overventilated when it comes to the total clean air flow for their space versus 241, which is an exciting finding for many of these companies because they can actually do energy and cost savings reduction opportunities around certain spaces in their building. And in the case of our system, which I talk about as an example here, we deliver that in a series of dashboards that enable you to create projects around your over and under ventilated or low clean airflow spaces that can be addressed over time and then measured again to recommission those spaces. So as mentioned, this is important. 40 to 60% of the operating cost of any building is providing conditioned air. As mentioned, we found that Class A buildings are often overventilated in areas. Using a very similar test to the 241 test, we ran one of the largest ventilation surveys to our knowledge ever done in Toronto, covering a huge variety of building ages, space types, measuring over 180 locations in that city. And this was our overall finding. So you certainly shouldn't be afraid to make your clean airflow measurements. And in fact, they may open opportunities for cost savings. And then in those underventilated spaces, they can often be addressed very cost effectively. Now that it's also been shown that providing clean airflow to spaces, using UV, using filtration or other methods can be done relatively cheaply. So, the opportunity at least is to reduce sick days for spaces whose ventilation system is optimized. And just as sort of a very small case study, we found that a 15% reduction in energy costs for a 200,000 square foot building can typically save as much as $52,000 annually. So chipping away at the energy cost through finding over ventilated spaces or high airflow spaces is quite attractive. One of the ways at Poppy that we've started to package this so that this can be done by anybody is using hardware that we provide. So this is an example of hardware. You can, for the 241 method, you can assemble your hardware as well, but we've been able to do this in a cost-effective package that provides specialized sensors with high accuracy particle counting in all of the relevant particle bins and nebulizers that in an automated way can make these 241 measurements quickly zone by zone in buildings. And we've been able to package this into kits that are widely available now, into an accredited professional program that you can train on as a new type of tab skill, and even packaging these for HVAC partners as well. So the kits provide real-time data. You can determine your ECAI and VECAI numbers on site, as well as EACH zone by zone. And as mentioned, using these kits, setting them up in a couple minutes, making the measurement over a period of about 20 minutes to half an hour, and then shifting them to another location, potentially having multiple kits running at the same time, can be a very scalable and cost-effective way to make these these measurements and provide ASHRAE 241 testing for new customers. So to just give you a sense of it, this is what are the components of any such kit. So you have sensors, your nebulizer device, battery packs, everything is connected to Wi-Fi and delivering data into the cloud. And this enables you to operate really efficiently in the space, digitally collecting the data and even diagnosing problems sort of as you go through the building. As mentioned, we built up a new accredited professional training program around the ASHRAE 241 normative Appendix C test. So you can develop your expertise in this area in about 4 to 6 hours. It's designed for adult learning. You demonstrate a completed verified 241 test as part of the training program, and then you can start applying this to your facilities if you're a facility operator manager, or to your customers' facilities if you're a contractor or service provider. So one of the things that we're excited to offer, as an aside, is 30% off kit subscriptions for the first 6 months through through those who contact us after this webinar, an HRAI discount. And if you want to get started on this, if you have questions about the standard, about 241, especially the particle decay test, which is what we specialize in, please feel free to get in touch. I'm sam@poppy.com. And with that, Matt, I'm happy to take questions as they've come up.
I'm glad you are, because we got a few for you. So
Excellent.
Get ready for these. We have some that came in before the webinar as well, so I'll mix those in. And one of those is, how does the standard affect other countries, or is this just for the US?
Yes, it's a great question. So like with other standards from ASHRAE, it's expected that ASHRAE 241 will be referenced or used in whole in other countries. So it will depend on how code is created and adopted. Building code is created and adopted in those countries. It hasn't been adopted into code yet anywhere in North America, but it's being considered for adoption in a variety of places right now. But 241 provides a toolkit and a framework for enabling infection control in any space from an airborne perspective. And from that perspective, it is a new standard that, in our view, would apply globally. And it happens to have been written in the US, but with international experts.
Thank you so much. One from the audience, Joe Mashinsky. What is a good practice to implement for ventilating a space when ambient air has low air quality standards, such as smoke from forest fires?
Yeah, so those types of questions are obviously best targeted to your HVAC specialist. But I think, one of the things I can say is knowing that you have a good quality outdoor air filter that can reduce particulate load in outdoor air coming in, and then providing additional filtration in the space or UV disinfection can be very good, cost-efficient ways to provide clean air to a space under the conditions that you have low quality low quality outdoor air. One of the things that I will mention is, as part of the 241 test that we provide at Poppy, we actually do verify smoke clearance rates for wildfire smoke infiltration, which is something that by implementing filtration in ASHRAE 241, you're also testing how quickly particulates are removed from the space within certain size ranges. So 241 and the particle decay test enables you to measure how quickly or how well that is working under conditions of wildfire smoke infiltration as well.
Thank you so much. And Joe is definitely an HVAC specialist, so maybe ask him as well. He'll probably know as well. Sure. The second question, can you do the test in really big or really small spaces? We have a huge open part of our floor and some smaller offices, and I think we'd want to know the scores for all of them.
Yeah, you absolutely can. There is a way of patterning the space to design your test or your sampling setup. And, we'd be happy to talk about that. But in general, you're measuring 10% of occupied space and 10% of replicate spaces within a building to do the 241 test. But it's certainly one that you can apply to every space if you want to as well, to understand really in more granular detail what the distribution of your scores are for your spaces and optimize each space that you have.
Right. Got two more questions left, but I'll just invite anyone who's listening right now to, if you want to pop your question into the Q&A button or the Q&A box or the chat, and you can also ask while we have some time. Yuri has a question. How do you account for occupancy changes over time or changes after commissioning? Is there a way to do continuous commissioning in some way?
Yeah, that's a really good question. So 241 enables you to select your occupancy. It doesn't have to be the maximum occupancy for your space. And in that respect, it enables managers to say, what is my occupancy this year, or what do I expect my occupancy to be this fall, for example, during flu season? And then we can commission and determine our VECAI number, our total clean airflow rate. We can determine and test against that with the 241 test determined by our desired or projected occupancy level. So that is something that you can certainly change year to year. You could change it season to season or quarter to quarter, and you could keep verifying or recommissioning using the 241 test. You could keep recommissioning as often as you like.
Thank you. For Mohammed, what commercially available integrated products can monitor complete IAQ, including PM 2.5, PM 10, CO, TVOCs, and bioaerosols?
So that's a great question. At Poppy, we provide quite comprehensive ongoing IAQ monitoring solutions. So outside of today's conversation, like, I would be happy to talk about your applications and what we can provide. Feel free to get in contact with me, sam@poppy.com. And I couldn't comment about what else is out there in the market, but we know that there's a variety of monitoring solutions. It can be challenging, though, to piece together sort of everything that you're looking for there. And so I would say that combining IQ monitoring plus 241 testing is some of the most comprehensive work you could do for indoor air quality and health safeguarding in a space.
Excellent. A final question for now is, can you conduct the test that you're talking about when people are in the space?
Yeah, the test is designed so that it can be used in occupied spaces. And so the selection of the type of tracer particle that we use, which is just salt water. Salt is something that's within us physiologically. It's in our environment. If you live by the ocean, there's salt concentrations in the air. And that's something that we actually had to look at and dig into the literature a little bit around when writing the test method for 241. That is the tracer that's used in the test, and you can certainly use it in occupied spaces.
Excellent. Good job. We ran through those pretty quickly. If anyone has some other questions, please put them in now. Otherwise, I'm going to start into my final ramble here. First of all, I wanted to thank you so much, Sam, for joining us. And I would invite you to come back later down the road and just kind of represent this or add some new information. That'd be fantastic.
My absolute pleasure. Thanks so much, Matt. Thanks, ASHRAE, and thanks everyone for joining us.
Yeah, thank you. And just before you go, like I said, if you'd like to watch this again or share it, it will be on ASHRAE's YouTube page within the next couple of days. And if you'd like to put on a webinar of your own for ASHRAE members, please reach out to me. This is the point where I should have my own slide, but you can find us on ASHRAE's website. Just reach out, ask how you can get involved, and we can do something similar as you're seeing right now. But until then, thank you. To have some time back in your day to finish that lunch, and we will see you all again in the next webinar.
Thanks, everyone.
Thank you. Cheers. Bye-bye.
Bye.